In looking at the underlying dynamics to many of the greatest governance issues of today, one can identify that they are inherently non-linear. For example, today's environmental challenges are often modeled in terms of the social dilemma and the tragedy of the commons, where certain types of interactions on the micro level lead to very different emergent outcomes on the macro level. Another such example of nonlinear dynamics is cascading failures, such as seen in financial crises, which are driven by feedback loops. Coupled to this are issues surrounding the butterfly effect, where small actors or even individuals can have an increasingly disproportionate effect, terrorism and cyber warfare being examples. Suffice to say, as the world becomes more interconnected and interdependent, it also becomes more nonlinear, and when that is the case, one needs to think in terms of nonlinearity in order to effectively interpret events, and likewise develop the appropriate institutional structures. The process of governance can be understood as a social function or institution that is designed to manage, make collective decisions, and guide the development of a community of people. In so doing, the institutions of governance have to, in some way, aggregate the opinions or intelligence of their members towards making decisions. Societies are invariably complex in that they consist of many parts. Nations today consist of millions or even hundreds of millions of people, yet their primary decision-making institutions may be constituted of only a few thousand people. Yet these governing institutions are expected to in some way represent the will or interests of the underlying much greater social system. A central question of interest then is how do we go from the micro level of the millions of individuals and distributed interactions to the macro level of the formal political institutions? An important question is how do we go from the vast, complex system of the populace at large to the centralized institutions of governance in a way that is representative of the large populace? Here we can recognize the current political challenges that we're having with populism, and likewise the issue of global governance can also be understood as a question surrounding emergence, as populism is driven by a disconnect between the populace at large and the small set of political institutions, that is to say the politicians and ruling elites. This ties in with the broader unresolved major issue of our time, global governance. The question of how we might develop political institutions that go all the way from the local level to the global level in a coherent fashion that is inclusive enough and representative enough to be robust against populism. The study of nonlinearity in politics and emergent non-equilibrium processes can help us better understand such issues. With linear models, the macro level is seen to be nothing more than the sum of the micro level. The whole is a simple aggregation or statistical aggregation of the micro level. That is to say, if we want to talk about the system as a whole, we use the process of generalizing, where we take the average and define the whole in terms of this statistical average. For example, if most Chinese people speak Mandarin as their primary language, then we simply equate the Chinese language with the Mandarin dialect. More formally, this process is called renormalization or coarse graining. Coarse graining is a term from physics which essentially means that we compress the information down into a reduced form. Like compressing an image on your computer, the computer uses an algorithm to reduce the small detailed variation down into a compact form. This coarse graining merges specific states of the world that have similar properties so as to reduce the underlying complexity. For example, we often coarse grain the voting system by taking an electoral area and instead of looking at all the details, we define it by the average, that is to say what the majority vote for. In such a way, we have coarse grained the unit, abstracted away from the details, and reduced the complexity. Because we've thrown out this information, it is now much easier to deal with the whole system, but also we do not actually know what is happening down below the level that we renormalize to. We have essentially thrown out a large section of the complexity. In simple systems, this underlying information does not matter very much. However, in complex systems, it turns out that it's important information. Various algorithms can be used to perform this process of coarse graining, but what happens when we renormalize or coarse grain through statistical averages is that we tend towards equilibrium. We take a complex distribution and search for the mean or average, then instead of dealing with all the details, we deal with just a representative of the whole. That is to say, the average comes to represent the whole, and in so doing we reduce the complexity. Of course, the result of this is that everything becomes based on this average person as a representation of the whole. Part of the problem of throwing out the variety in this way is that you also throw out the particularities of the individual. The individual no longer matters, it is all about the mass average person. This is the essence of mass media politics. It's all about appealing to the average of the mass. And this should be something that we can identify with, as politics within developed economies has evolved into media politics and left behind to a large extent its ideological roots. There has also been a tendency towards the center, because in this kind of system, if you are the average then you'll win, if you're on the fringes then you lose. This dynamic creates strong incentives to be the average, both for the members of the population at large and also for the politicians. Because if you can appeal to the average, then you'll win. Variety is not accounted for and it is dumbed down. One person, one vote, irrespective of any variety among the members. That one vote gets bundled up into a huge mass and averaged out. The end result is, if you're on the fringes, you will virtually always lose. Over time, this places a force on the agents to move back towards the center. The results of this are macro-level equilibrium outcomes. On the micro level, the system is configured to push the members towards the average, and the result of this on the macro level is an equilibrium outcome. Equilibrium analysis has been an essential tool of modern science. It's been a powerful tool that has given us much insight and traction on phenomena that were otherwise beyond our grasp. Equilibrium analysis is helpful in many ways, particularly in simpler systems and stable environments when a system is in a stable basin of attraction. However, it will not tell us about major processes of change that inherently engender non-equilibrium dynamics. Thus, it will not tell us about a lot of things that we're really interested in. The unfortunate thing about equilibrium analysis is that it is really a shortcut that bypasses complexity, and in so doing it gives us some insight into systems that are complex, but it does this by ignoring the complexity through coarse graining and averages. This is not a major issue until you actually start to take an interest in the complexity itself, in which case a tool that purposefully bypasses it is not going to be of much use. One then needs to shift to nonlinear models that allow for non-equilibrium outcomes, which are characteristic of many social phenomena and particularly characteristic of major processes of change. Non-equilibrium is fundamentally a product of the interaction between elements within the system over time. When we turn up the interconnectivity, interdependencies come to form and the system goes from linear behavior to nonlinear behavior. Correspondingly, we get non-equilibrium outcomes on the macro level because of synergies in emergence, and also non-equilibrium processes of change over time, driven by feedback dynamics. The statistical output of nonlinear systems moves away from a normal distribution, which is dominated by the average, and tends to follow a power law distribution, where there are a very few very large events, and a very many very small events. Outputs do not tend towards an equilibrium average. Instead, they tend to diverge the larger the sample we take. The normal Gaussian distribution and the power law distribution differ radically. The main feature of the Gaussian distribution can be entirely characterized by its mean and variance, while a power law distribution does not show a well-behaved mean or variance. The power law distribution, therefore, has no average that can be assumed to represent the typical features of the distribution, and no finite standard deviations. When one looks at the different kinds of power law phenomena, we will see that underlining each is a collapse of the independence assumption, which is central to getting a normal distribution. Once the independence among data points is removed and interdependence or interaction occurs, then we begin to get power law distributions, and this changes the overall dynamics of the system in fundamental ways. Unlike in linear systems where the average value tells us a lot about the underlying variables, with power law distributions, the average does not tell us much about the particularities of the variables underneath it. Thus, we cannot use the average as being representative of the whole system, and coarse graining through statistical averages stops working. For example, if we had a population with a wealth distribution that was a normal Gaussian distribution, most people would have the average income of, say, $30,000, while few would have very high or very low incomes. Thus, we could craft an economic policy directed at the average and expect to affect the whole system. However, with a power law distribution, there will be a handful of people that are extraordinarily wealthy, while the mass of people will be relatively poor. The power law distribution is also called a Pareto distribution, or more popularly known as the 80-20 rule. It was named after the Italian economist Vilfredo Pareto, who observed that 80% of income in Italy was received by 20% of the Italian population. We can also note that today, the net wealth of Americans is in fact distributed according to a power law, and this corresponds to what has been identified as the hollowing out of the American middle class. In a world of power law distributions, extreme events become much more prominent. Extreme events can take many forms, such as extremely wealthy individuals, or sudden and severe disturbances like a Class 9 earthquake or a financial meltdown. Extreme events like this, that in a Gaussian world could be safely ignored, are not only more common than expected, but also of vastly larger magnitude and far more consequential in the world of nonlinear systems and power laws. These extreme events have an interesting property that they emerge first in the long tail, which is the portion of the distribution having a large number of occurrences far from the head or central part of the distribution. Once they start on the long tail, positive feedback then gathers their momentum until they eventually break into the mainstream and change the game for the mass of the people. The challenge for public representatives is to sort out the signal from the noise in the long tail and spot early on the emergent extreme events that could reshape the landscape. The Gaussian focus on averages obscures these events, treating them as meaningless outliers where they get lost in the process of statistical coarse graining. In such circumstances, new events only become noticed when they hit the mainstream, at which time they have already grown high momentum and it is no longer possible to alter them. Because of this, in complex systems, people sometimes say it's the tail that wags the dog. This means that because of heightened interconnectivity and interdependence, there is a much greater possibility for positive feedback to take hold. Small events on the fringes can get amplified into large changes. Change starts on the fringes where there is diversity and space for experimentation, then through feedback moves into the center. Because of heightened connectivity and compounding feedback, the move into the center can happen very quickly. If you focus just on the mass, average in the center, you will continuously be shocked and surprised, becoming vulnerable and reactionary. What happens is that when we coarse grain, we throw out the detail. Because the diversity lies at the edges of the distribution, by basing the abstraction on the mean average, we also throw out the diversity within the system, and in complex systems this has significant consequences. The diversity and variation of the actors comes to be a critical element which cannot be ignored. This is increasingly an issue we face as the world becomes more nonlinear and complex. While models and institutional structures remain linear, we are continuously presented with surprises and shocks, with the result being a reactionary mode setting in. In a research paper on the subject by McKelvey and Boisot, they described the Gaussian perspective of the world as one built on atomism, privileging stability over instability, structure over process, objects over fields, and being over becoming. There is a natural and very human tendency to generalize so as to simplify, to seek out the typical or the average, and to search for more predictability. In linear systems, it is mainly the equilibrium that matters. In nonlinear systems, though, it is both the little parts that matter and also the overall emergent patterns. You cannot just affect the average in order to affect the whole system. You need to dig into the complexity of all the parts and understand the variation to identify the specificities of the system. You have to know the details of the individuals and how they're connected. Previously, this was not possible within large societies, but with the advancements in computation, the wealth of new data sources coming from all directions, and new computational models, this is increasingly possible. Dealing with nonlinearity invariably means using computational methods, because one has to deal with all of the little parts and their diverse characteristics. This requires a massive amount of information and computation. This is not simply an academic exercise, though, as information technology plays the same central role in the practical design of political institutions that are appropriate for managing complex social systems. When the complexity of the larger social system goes above a certain level, the system cannot be effectively coarse-grained into a linear model of representation. In order to harness the complexity and diversity in the broader social system, political institutions need to be direct, that is to say, peer-to-peer, and information technology now makes this possible even within very large societies. The linear political institutional model of the industrial age, based on a representational political system and mass public opinion, was constructed around the constraints of the available technology of mass media one-way communications and the need to manage the newly formed mass population of the nation-state. However, as the influential author Clay Shirky notes, what is special about this current wave of information and communications technology is that it enables not just one-to-one telecommunications, as was the case with the telephone and telegraph, neither just one-to-many communications, as with mass media like the radio or television, but for the first time in history, many-to-many communications, and this is a game changer that is currently reshaping virtually all social institutions, from business and commerce to media and entertainment. These collaborative platforms are reshaping organizations in enabling unmediated and automated interaction and collaboration between many people through which they can make collective decisions and coordinate towards implementing and enforcing them. Political institutions may well be the last to experience this transformation, but it would appear unlikely that they can somehow avoid it and remain relevant within a network society. The rewards for achieving a better understanding of how to operate in a nonlinear world of power law distributions are certainly enormous, and the results of staying within a linear model are diminishing with every new connection. As can be seen in the phenomena of viral videos on social media, small moves, smartly made, can lead to exponential improvements provided they leverage the deep structure that defines nonlinear systems. In contrast to the scaling strategies that worked in a linear world, different and even more powerful scaling strategies become feasible in a nonlinear world of the internet and globalization. The only question is, who will manage to leverage them? Will it be the makers of ISIS or the makers of Wikipedia? Of governance can be understood as a social function or institution that is designed to manage, make collective decisions, and guide the development of a community of people. In so doing, the institutions of governance have to, in some way, aggregate the opinions or intelligence of their members towards making decisions. Societies are invariably complex in that they consist of many parts. Nations today consist of millions or even hundreds of millions of people, yet their primary decision-making institutions may be constituted of only crises, which are driven by feedback loops. Coupled to this are issues surrounding the butterfly effect, where small actors or even individuals can have an increasingly disproportionate effect, terrorism and cyber warfare being examples. Suffice to say, as the world becomes more interconnected and interdependent, it also becomes more nonlinear, and when that is the case, one needs to think in terms of nonlinearity in order to effectively interpret events, and likewise develop the appropriate institutional structures. The process of the large populace. Here we can recognize the current political challenges that we're having with populism, and likewise the issue of global governance can also be understood as a question surrounding emergence, as populism is driven by a disconnect between the populace at large and the small set of political institutions, that is to say the politicians and ruling elite. This ties in with the broader unresolved major issue of our time, global governance. The question of how we might develop political institutions that go all the way from the local level to a few thousand people. Yet these governing institutions are expected to in some way represent the will or interests of the underlying much greater social system. A central question of interest then is how do we go from the micro level of the millions of individuals and distributed interactions to the macro level of the formal political institutions. An important question is how do we go from the vast, complex system of the populace at large to the centralized institutions of governance in a way that is representative of. In looking at the underlying dynamics to many of the greatest governance issues of today, one can identify that they are inherently non-linear. For example, today's environmental challenges are often modeled in terms of the social dilemma and the tragedy of the commons, where certain types of interactions on the micro level lead to very different emergent outcomes on the macro level. Another such example of nonlinear dynamics is cascading failures, such as seen in financial